a series of two fractions subtracting each other? And if it's not, you have to decompose. Then it becomes two fractions subtracting each other. So that's usually what happens. But that's very, um, it's not rare. It's more often on competition, but it is still kind of rare on AP exam. But it doesn't mean that they don't give it to you. So you are gonna have telescope series on the AP exam, but just not as often. Ilya, I don't know if you watch the video, but it's really important you watch that last 2 days video.
All right, I watched some of them, but I'm kind of unconscious, so I'll watch them again.
Okay. So yeah. So it turns out there's a lot of trauma going on in this class. Yeah, we got people get kicked by the horse and people fall off the bike. You did a good.
That's wrong.
Yeah, that's actually mine. She must be made of steel. I would have. Wait, did he kick her?
Yeah, he did.
Kick in the face.
Damn.
Oh.
Yeah, exactly. That's what I'm saying. I would have died.
Yeah.
I mean, I just want to ask.
You probably have a fast reflex, like
But she.
otherwise that's the.
Now, how did she like?
Otherwise,
Oh my god.
Come on, now.
all right. So so hopefully you know what's the setting of a telescope series. The setting is either two fractions subtract each other, or it's a fraction can be decomposed into two fractions. So usually denominator is factorable. That's a good hint. If its denominator is factorable, you can decompose. Does that make sense? So which is second question you did yesterday. So today we're going to talk about geometric series. But let's go back and talk about a long time ago. There was a geometric series formula, which is that's something that we're going to start with. Okay. So what is geometric series formula? Geometric series is going to be in always the setting is n equal to 1 and infinity of a1 times r to the n minus 1. Now it's really crucial that you know why there's an n minus 1 there, because when we talk about geometric series in algebra 2, we actually just talk about, well, a to the n is equal to a1 times r to the n minus 1. The reason why is the a1 there is the original value. So for example, if you have bacteria, let's start with bacteria amount. And let's say if you have 3 bacteria, that's going to be 3. And double every 2 minutes. So double every 2 minutes. So that's going to be n minus 1. So this is bacteria, right? Double every minutes. So you can actually come up with this. You can say, oh yeah, okay, well that kind of makes sense. If you got we're gonna say this is an x instead, so we can put in a function. So x and y. If it's 0, then it's gonna be oh no, sorry. If it's a 1, wait, hold on a second. Did I mess up? Oh, sorry. Geometric series formula is the growth equation is a1 r to the n. But in this case, you wanted to have n minus 1, so it's a little bit different than geometric series. So geometric series has n minus 1 here. That's a very, very important. So let's erase this. That's not a good example because in terms of that, it's going to be that's x. So that way it's going to be double every minute. But this is the a1. This is your beginning value. Then what we're going to talk about is when is converge and when is diverge. So when it's converge is when r is equal to what? R is less than what? Why? Well, yeah, but also if it's greater than 1, then that's gonna be, it's gonna keep on growing, right? And just like you're saying, it's decay. So I'm going to change this to absolute value. That's actually better because it could be negative. So if it's converged when r is less than 1, because you're going to multiply itself and keep on multiplying.
It's an R.
Yeah, r. So that means the r can be between -1 and 1. So anything that value between -1 and 1, but not including 1, it can be converged. It's a diverge is when the absolute value r is greater or equal to 1. Is that okay? And so there is two series you can actually find a value. So one is telescope and geometric. Can be evaluated. So for example, let's say r is equal to half, right? That is going to be definite because if you have a half a pizza and if you eat half a pizza and if you eat half a pizza, then eventually it's only going to grow to the whole. So there is, even you adding, it's still going to sum up to be a finite number. But if you eat one pizza every time and you keep on adding, then the pizza is still going to grow. Does that make sense?
Say that last part again.
Like if you eat one pizza, then the total amount of pizza is still growing. But if you eat half a pizza and half a pizza and half of that same pizza, keep on eating half, then you only can grow up to the whole pizza. Even you eat 3/4 of pizza. So let's say you eat 3/4 of pizza and whatever left over, you eat 3/4 of it. And whatever left over, you eat 3/4 of it. You're still going to be grow into the finite number. Does that make sense? Yeah. So then you got to say, well, what happened here? Now we got to say, how do you come up with this formula? This formula is going to be very, very well known. This is going to be known as, I would say this is always something to go to. So this is probably like one of the most important formula that in the series, which is 1 minus r. Summation of a to the r to the n minus 1 is equal to, always equal to, a over 1 minus r. Always. I'm going to show you a proof. A proof is start with a geometric series. You learned algebra 2. That looks like this. Have you seen this formula before? Sn equal to a times 1 minus r to the n over 1 minus r. Have you seen this before? Kelly, put that thing away. Okay. Have you seen this before? 1 minus r to the n over 1 minus r. Actually, Kelly might have seen this equation before. College algebra. No? Don't remember? Geometric series? No? Okay. So this is the formula that I will assign for the worksheet. The worksheet, you're going to have some homework question that involve this, but it's not going to be in calculus exam. So if it's a finite, so let's say if it's a finite term, so this is a finite series, this is finite. Finite geometric series. So you stop at this term, then you can plug in this formula, you know all the things that's add up. But I'm going to show you what happened here. This is what happened. So if you have a summation of n equal to 1 of infinity of a to the r to the m minus 1. I'm going to write on first few terms. I'm going to say Sn is equal to a plus a times r, because every term I'm going to multiply by r, right? Plus a to the r to the square plus 8r to the third dot 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 until a to the term at the end, which is your last term at this particular case is the a to the n minus 1. AR n minus 1. Okay. Now, can I multiply this by Sm by r? So I'm going to multiply by r. On both sides. What will happen? I will get r times Sn. Does that make sense? AR plus AR squared plus AR to the third plus dot 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 dot. But your last term is going to be AR to the n. Because you multiply by r, this one will cancel out, right? The negative 1 will cancel out. The positive r and negative r to the negative 1 will cancel out. So what I do is I multiply those both sides. But I can subtract two equations. I can subtract the Sn minus r to the Sn. What happens if you subtract them? What happens if you subtract them? You do get a in the front, but what happened everything else? It cancels this way, right? Right? So whatever this term will end up canceling out because you have one less term here. So whatever here, let's just imagine there's a term here, is going to cancel out with this term, right? And you left with a plus a to the r to the n.
A minus.
Oh, a plus, a minus, yeah. Because you're subtracting. Okay. Okay. Now, what happened is I can figure out what is s to the n. Factor out. And then Sn, you can solve for it. And you can even factor out A. And that becomes a series, a finite series. You can plug in this equation, you can find out series. If the series ends at 4 term, you can find out S1, S2, S3, S4 out, no, A1 plus A2 plus A3 plus A4. You can add up those 4 terms by using this formula. That's called finite series. You learned this in Algebra 2. Nobody remember it, but you learned it. But now you relearn again. Yes. What? Because it's so loud. Okay, so that become a finite series. Now what if a term is infinite? What if it's a r is less than 1 and the term is infinite? Right? So we say, what if this n equal to 1, infinity a to the r to the n minus 1 is equal to limit n approach infinity of Sn if I have approached infinity. And you gotta pay attention to the r. The r is what? Greater than 1 or less than 1? We are assuming that it's converged. So we're assuming converge. So r is, let's just say, less than 1. The absolute value of r is less than 1. Now what happens if you have limits as n approach infinity of a times 1 minus r to the n over 1 minus r. What happened if this reach infinity? You remember, 1/2, imagine that r is 1/2, right? And if I have infinite, what will happen to this term?
Why is 1/2?
We are assuming r is less than, I just pick a value.
Oh.
Between -1, but I'll pick a 1/2 because it's easier to visualize. Yeah, assuming converge, then r is between, what is 1/2 to the infinite? 0. So what it becomes a 1 minus r, because this whole term will goes to 0.
But then it's, oh,
If it goes to 0, that becomes this. And that's an infinite, it's called infinite series, infinite geometric series.
so you just made a finite series infinite.
Yeah. We are assuming R is converge. The prerequisite is you have to assume R is converge. Now, it doesn't matter. Even 3, 4. 3, 4 to the infinite, right? Then it's going to be 3 to the infinite compared to 4 infinite, but 4 infinite is way outweighs 3 infinite. Still going to be going to 0. If it go to 0, then you can apply this equation. Does that make sense? Okay. Just imagine that you have the 1 pizza situation. The first day, I'm going to eat 1 pizza. So 1 pizza. The second day, so this is the first day. The second day, I'm going to eat half a pizza, right? The third day, I'm going to be what? 1/2 of a 1/2, so it's a 1/4 of pizza. Right? So it keep on going. Does that make sense? So your A1 is what? A1 is n approach infinity, and well, n equal to 1. Sorry, n equal to 1, and it's infinity. A1 is what? 1 pizza, right? Times 1/2 to the n minus 1, right? Because n equal to 1, then you're going to have equipped to this, right? 1, the first term is n equal to 1. 1 subtract 1 is 0. 1/2 to the 0 is 1. Is that okay? The second term is going to be 1/2 plus 1/4 to some other value. So we're assuming, how do we find this? All you gotta do is plug in the 1 on the top. 1 minus 1/2. Then that's equal to 1 over 1 over 2. 2 pizza. First day you eat 1 pizza. Second day you eat half of the pizza. The third day you eat half of the pizza. You get 2 pizza eventually. Geometrically makes sense. First day you eat 1 pizza. Second day you eat half. The third day you eat another half. The fourth day you need another half. And you keep on going until it goes to the 2 pizza. Is everybody understand so far?
So this is for the infinite.
This is for infinite. That's if you keep on eating half of before. Half compared to the day before.
So what about the example of finite?
Finite, then you got it. Let's just say, okay, let's try finite. Let's do third term. Is that okay? Try the finite. Let's try the finite. Let's get an example. So let's try S3. What is S3? A is 1, right? 1 minus half to the what? 3, right? Is that okay? And 1 minus what? 1/2. Is that okay?
Yes.
So that is going to be 1 minus 1/8 over 1/2. So that is going to be what? 7 over 8 times 2 over 1, right? So that's 7 over 4. Is that right? 1 plus 1/2 plus 1/4 is what?
Oh, okay.
7 over 4. So we prove finite works and infinite works. And coming from a simple manipulation by multiply r on both sides, subtract both. I don't know who come up with this shit. That's really smart. Like, how would you come up like say, oh, let's just multiply both sides by r, and not just subtract both terms, and they'll cancel out most of the thing, and you'll get a minus a times r over n.
So the point is to get a finite value.
At first, they were trying to get a finite value. They want to come up a way to calculate a finite series. What if I want like s to the 10 term, right? I can just plug in and they can evaluate it. And later, somebody says, wait, if we learn about calculus, what if the r is less than 1? Then if it goes to infinite, that's going to be 0. And then boom, a over 1 minus r. So the calculus kind of invented after the algebra. First, this was a pure algebra manipulations. Pure algebra manipulation. Later, we have limits now. So limit and approach infinity. So the r to the n is going to approach infinity. So if that part, r to the n, is going to go to 0, and that becomes this new series will always work. Even work with negative number, believe it or not. That's a negative 1/2, right? They will work on the same thing, on a finite or infinite, which is really, really cool, I thought. It's something that I thought is very interesting, and it really changed math completely different, especially calculus too. So I want you to find out what the geometric series here. What if I just ask you n equal to 1, infinite 3, and that's negative 4 over 3, n minus 1. What do you think about this one? This one's what? Diverge. That's it. Super easy. Why? Because r is greater than 1. You're done. You just have to recognize that r is greater than 1. Right? Even though that is negative, but we're talking about absolute value. So absolute value of negative 4/3 is 4/3. And 4/3 is still greater than 1. So does it diverge? We don't even need to do math.
We get a question like that on the test.
Huh?
The exam.
Diverge? Very rarely. They want you to think, yes. Is that okay? So that's diverge situations. Now,
With convergence with r between negative 1 and 1.
it converge, yeah. So what if I have a summation of this? Let me see. What if I have a summation of this? I have a summation of some type of series, n equal to 1, infinite, an. But I'm going to just write out the first few terms to show you. The first few term looks like this. 5/3 minus 5/9 plus 5/27 minus 5/81. Dot, 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 dot. what do you think this series? How do I write this series in term of summation of n equal to 1 infinite an, and we can write it in term of a1 times r to the n minus 1. How do I write it that way?
A is equal to 5. Yeah.
A equal to what?
5.
No.
Oh,
A is not 5. U-dou is 5. Can I do some type of math first? Well, what kind of math I would do here? I don't want to add them together, of course. You want the first thing result to be 1. How do I make it that 1? No,
Subtract 5/3 or no?
not subtracting. You're on the right track though, 5/3, but not subtracting.
Raise it to the power of 0.
No.
Like 5/0 over 5.
What?
Multiply by 0 over 5. Yeah.
Almost. No.
Subtract over 3 divided by 5.
Divided by 5/3 is a good idea, but instead of dividing, what can I do? No.
But we divide by
The F word in math. The F word in math.
factor?
Factor.
Oh. Yeah, that one.
So can I factor out a 5/3? What happened if your next term, that's 1, right? Minus what? 1/3 plus what? 1/9 minus 127 dot 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 dot, right? Because you want this to be, you want to n equal to 1, that is gonna give you the first result. So you want this is a1. Ideally you want this is a1. So you can rewrite that. You can say, oh, okay, now I can rewrite the right way. So I can say, well, n equal to 1 summation, and that is gonna be 5/3 is your a1. R is gonna be what?
Negative 1/3.
Negative 1/3. Good. And now, why is it that n minus 1? Think about it. If I plug in 1 here, what am I gonna get?
1.
1 minus 1, which is 0.
Yeah.
And negative 1/3 to the 0 power is 1, which is your first term. You wanted it to be 5/3. Does that make sense?
Wait, how do you know R is negative 1 2?
Well, you see, oh, that's a good question. In algebra 2, you learn that. You take the a to the n plus 1 over a to the n. You take the next term, divide the previous term, is equal to r. So that's just a negative 1/3 divided by 1. That's equal to negative 1/3. And it has to be at least 2 terms works, right? So 1/9 divided by negative 1/3 is what? Negative 1/3. So this is called common ratio. That's a great question, by the way.
what did you do?
I take the a to the n plus 1 over a to the n. This is how you find in algebra 2. How do you find the common ratio? Take your next term divided by the prior term.
How does 1/9 over 1/3?
Third term over second term. So you take one term, so take one term and the term before that. What? It's a to the n minus 1.
Saying the number after. The number.
Oh.
Okay, you got it?
Yes.
Okay, I'm gonna give you a question to you, and you're gonna try to do it. N equal to 1, infinite, e to the n over 3 to the n plus 1. The idea, you want to somehow convert it to this. I'm gonna give you a hint. It has to be, it has a, has n minus 1 over there. n equal to 1, infinite. If you can convert this form to this form algebraically, then you'll be okay. Then you know what to do after that. So the thing is, the hard part is how do you convert that to that form? And if you convert that to that form, then you can use a over 1 minus r. It's a lot of like exponent rules. Make sure you understand exponent rules. You want it r to the n minus 1. I'm going to say that again. R to the n minus 1. Convert this to this form. And r has to be less than 1. That's a very tricky question. Should I give you an answer or no?
Not yet.
Okay, let's try this. Should I try or no? You want to answer first? The answer is right there in the front if you want to look at it. So let's try to convert this. So obviously I'm going to take out one term. I'm going to do it 2 steps. That's going to be e over 3 to the n. But ideally, you want to n minus 1, right? Would you say you want to n minus 1 because this is the n? Did you see what I did mathematically? I want to n minus 1, so what can I do? Can I take out another e in 3? And that becomes minus 1?
Even.
Oh my god.
That's just defining.
So we know the. Now you gotta be careful of this because you have to understand the value of e. E is greater than 3 or less than 3? e over 9 times e over 3. Is this r greater than 1 or less than 1? R is less than 1. Great. Converge. Now we got to find the sum. So only in telescope and geometric you can find the sum. Throughout whole calculus too, I think this is the only two situation. Integral tests come in pretty close, but it's estimate sum. It's not a real sum. Not yet. Now I'm gonna do 1. No, actually not 1. It's A1, which is what? E over 9, right? 1 minus E over 3. So that's E over 9. And over 3 minus E over 3. That's equal to E over 9 times 3 over 3 minus E. And this will simplify down to 1 and 3. So it'll be E over 3 times 3 minus E. And that was my answer.
Wait, if you got the series, how do you get the answer? So you did the NA of that one, like, over 3 and
Where did you
minus 3 to 1. Sorry, okay, first start. And this is additional, there's this 1/3 and 3 to 10. Because this is a common base, I'm just put here, it's 1/3 e to 3 to 10.
This by that.
But you gotta make sure the R is n minus 1. So that was a kind of funky part. And then the only way to do that is take out E over 3, just like factoring. But then on the back side, it's gonna be n minus 1.
Again,
How many people don't get it? Raise your hand. Devin? Okay, which part you don't get?
in order to, well, you took out e for 3 second time. Yeah.
How do I factor out? Okay, good question. So if I take out E and 3, right? So this part is going to be subtract by 1. This part is going to subtract it by 1. So that's at E over 3 over N. Can I multiply this E over 3 times E over 3 times N minus 1? This is the part you have question, right? Think about it. This one is going to be E over 3. This negative 1, that means what? E over 3, that means 3 over E. Right? Does that make sense? Because E to the E over 3 over to the negative 1 power is what? 3 over E.
Oh, that's how you found R2?
That's how I found. How did I get to? Oops.
Because I know how you get to eat it over 9.
Or you can think about this. That's another. Let's see. What's another way to think about this?
I just plugged in numbers
Yeah,
and
just
then
do how you did the
factor.
plastic. Plug
You
in
can plug in 1
N equals
and then
1 equals
2.
2,
and
and you
then-
can factor out
yeah.
E over 9
Yeah.
Yeah.
to get A1. You just do the function.
Or yeah, you can do it that way. That first way that I introduced. Now this way, you just have to understand your exponentiation rule, because if you e to the 3, this means is 1. Now this part has to be subtract by 1. It has to be subtract by 1. It's just a, I think it's a product rule of exponent rules. Does that make sense or no?
Yeah.
I mean, take a moment to think about it. It should, it should be okay. But next series you need to know. So we learned how many series? Telescope. What else? Geometric. R has to be less than 1. We got infinite series is A over 1 minus R. We're going to talk about the last one, the next one. The next one is actually very easy. It's called harmonic. Yes.
So if you figure out its diverge, you just stop right there.
Yeah, diverge done. If it's diverge, that's like thank Lord. Yes, I'm stopped. I'm not gonna do any more math. Diverge done. You are the greatest of all time, Michael Jordan. You're done. Is that okay? You're Marcos, you suck at basketball. You Donald Ye, you worse than Marcos, so you even suck even worse. But again, that comparison's actually interesting because if you're less than Diverge, doesn't mean that it could be your Diverge or Converge. Because you're less than Michael Jordan, it could be you are still LeBron James. You still Diverge, right? Or it could be just Marcos, then it's Converge. Converging. You are horizontal, asymptote, and converging. What'd you say?
I'm gonna make a box.
Box. Why is box? Another interesting this one is always diverge. This is diverge. But this one doesn't have R. If you pay attention. I didn't multiply by same number each time. Because last one is 1 plus 1/2 plus 1/4 plus 1/8. This one's 1 plus 1/2 plus 1/3 plus 1/4. Think about in terms of pizza. I eat one pizza. I eat half pizza. I eat 1/3 of pizza. I'm still growing very, very, very slowly. So this one, diverge. No, it's not 2. By the 3rd term, you're already more than 2. By the 4th term.
Wait, so
By the 4th term, you are more than 2.
It's going to infinity.
It's going to infinity. This is a very famous series. It's called harmonic. Harmonic series. I'm going to repeat again. We learned telescope. You can find a sum. Geometric. You can find a sum. Harmonic. Always diverge. Harmonic is Michael Jordan. It's that diverge. Actually, harmonic is more like I don't know, Kobe Bryant, and like I don't know, LeBron James.
what's changing? Yeah, what's changing?
They are the borderline of they are the borderline to the diverge. They are the line. They are the
Mr. Gaines, you think Michael Jordan needs to go? Tell me why he's not in Fortnite and LeBron is.
okay. So LeBron James is a GOAT at flopping. Have you seen that he goes like people touch him, he goes like, oh my knee. But he did that when he was 19. He did that when he was 19.
Listen, he's busy doing like Sprite commercials and stuff now, right? Like,
He's as good as he was since he was 19.
He did that when he was 19. He was a better actor now.
He did the NBA when I was in my dad's.
That's a movie, actually. Yeah. That cartoon.
Wait, what happened? He's your dad?
No, I was. He was already in the NBA when I wasn't even a thought. I wasn't even born.
That's true.
Not like an 18.
Like Sean Anderson. Me and him will go at it all the time.
Yeah.
Wait, all you guys think LeBron's better than Michael?
I can make.
Again.
I don't watch.
I don't watch basketball.
LeBron.
Yeah, I know.
Marcos, you think Michael's not as good as?
I think Paulo Banchero is the best NBA player in history.
What? You make one shot?
No, he's made multiple shots.
He has a better rookie career than Michael Jordan did.
Yeah, facts.
Finals? Huh?
He's on the Magic. He's on the Magic.
LeBron
Oh.
has a playoff record than Michael Jordan.
LeBron has better.
Playoff record.
No, not Michael Jordan has a
Playoff, not finals.
finals. Never win the game 7. I don't know.
LeBron took the championship. He won the Kings.
Yeah, but Michael Jordan never went to game 7. No. Oh, he got eliminated a few times.
Yeah, they got eliminated.
But how many times might LeBron James get eliminated in the finals?
Good amount of time.
Okay. Anyway, let's keep on going.
J.R. Smith.
So, harmonic diverge. So we know three series right now. Telescoping, that can find a sum. Geometric can find a sum. Harmonic cannot find a sum. Harmonic is a borderline of things. Is a borderline diverge because if you have 1 over n to the 0.99, oh no, sorry, 1.01, then it's automatic converge. If you 1 over n to the 1, then it's diverge. So that is like a borderline. So a borderline. Again, I'm gonna repeat again. 1 over n to the 1.0001, this converge. Okay? This converge. Because something called P series, but we're gonna talk about that later. So 1.001 converge. If it's a 1, then it's diverge. If it's less than 1, diverge. Got it?
Yes.
Okay. Harmonic series. That's next one.
Is that what it-
I
what-
thought you
what
said
was
that was what it was.
This is converge.
Well, what is that?
Huh?
Is
I
it
thought you
the
said that's
harmonic?
for the harmonic series.
1 over n is harmonic. 1 over n to the 1.0001 is converge. Due to, okay, fine, I'll teach you right now. Due to P series tests.
No, let's do that later. Let's continue with what you were about to do.
Okay, do the P series test. And the P series is very easy. If you have 1 over n to the P, if P is greater than 1, converge. Is it, yeah, that's what I'm saying. P is equal to 1. P is equal to 1, then it's diverged. Marcos. It's Rocco. I always get confused between two laughs. Wait, who is who?
Both laugh and think Shakespeare.
If you put me in a dark room, I won't know who laughs.
That's his. That sound is his.
Okay, so got it?
Wait, is it absolute value of P is less than?
No, not absolute
Yeah,
value of P.
it's-
Because
yeah, it's not-
P is negative 1, then it's actually diverge. P negative 2 is diverge because it will flip up to the numerator, right? So it is not absolute value. Only the R is less than 1. Is that okay? P series super easy.
Yeah.
You can manage P series, right? You can manage geometric series, right? Okay, so let's go. How much time I have?
Like 30 seconds. Like 30.
All right, you guys have homework.
You said it.
How much, Mr. Yang, listen, I think my little sister would appreciate that I celebrate her birthday. So can you please reduce the homework?
No.
Come on.
It's
My
easy.
little sister, she's turning 9. She's turning 9.
You have another
No offense to their sister. I don't give a shit about their sister.
9-year-old sister?
No. I don't even care about my own kids.
Oh.
Wait, am I streaming? Shit.
Yeah, you are.